Hello, everyone. Good afternoon. It is now 3 o'clock, so we're going to go ahead and kick off session 8, Introduction to Data Best Practices. Some quick, just administrative items before we get started today. If you are just joining us or maybe missed our introduction or other sessions, please just remember to stay muted to minimize interruptions. And then also, please make sure that if you do have any questions or anything that needs addressed, please put that in our chat. That way, at the Q&A portion of our sessions, we can go ahead and get those answered. All Q&A will be published regardless if the question gets answered during the session or after the fact if we do run out of time or have more questions than we have time for. So with that, I'm going to pass it over to Dan Anderson, Senior Staff Engineer on QDAS, for our session today.
Thank you, Julia. Let me go ahead and share my screen. All right, looks right. Okay, so
Looks
today,
good.
all right, perfect. Thank you. So for those of you who don't know, my name is Dan Anderson. I've been with this project a little over 18 months now, working with QDAS, and of course, I think I'm in the same boat as many of you, although I have a background with like a lot of these open source languages and stuff like that. I've primarily been a SAS programmer most of my career. And I was hired on as a SAS programmer. And then they immediately flipped us over into this open source world. And so these are some of the best practices that we've identified and would love to share with you. It's going to focus a bit on some of the content that we've done in some of our office hours with sessions 1, 2, and 3 primarily. But at the same time, everything's been changing. That's one of the difficult things about this project has been that, as you've seen today, we're talking about features that will be available once we get Unity Catalog up and running. Well, prior to getting Unity Catalog, everything when we were on Ambari was a different Metastore. And even now we're using a different one than what it was. It's kind of a transitional one. And so we'll go through this and we'll see that as there were certain practices that were essential at one point in time that are now antiquated, but also, these are kind of the best practices for the time being. I will try to point out certain things that we know will be changing, but these are still, nothing's going to break if you implement these changes. So these should be forward capable of course, famous last words, but that's where I wanted what I'm hoping to share with you today. So as an intro to this, my primary goal out of this whole session and when we were designing this course was really for everybody to kind of get greater familiarity with the environment architecture, also understand better about where data is currently located and also like in what locations we can access things from and what are those intentions of those locations. And then some additional best practices for accessing data, processing data, all within our current CDR Databricks environment. So I'm going to start first by talking about the data and taking a data-centric approach, talking about, where is the data? Why, everyone talks about, we hear about S3 mounts. Why do we have to use these? Unified File Management, UFM, what is it? And then, of course, the famous one of where should I be storing my stuff? Well, stuff is we have all sorts of types of data. So I'm going to try to simplify this as much as possible and make it, and give you some take-home tables or just images that you can use for your own reference. Additionally, what are the best practices for processing our work? There are different types of compute clusters, and there will be more coming forward in the future. And so, but what is currently the best practice? What do I need to keep in my mind? And then finally, I'll do a summary. I will tell you that although I can be a little verbose, when I have timed this, it's coming a little on the shorter side, probably about 35, 40 minutes. So feel free to have some questions and pop those in there as you come through. All right. So what is, our goal with the CDR? Well, the CDR is to employ is employing in a modern architecture to support the needs of modern data. It means, namely, the import, analysis, and storage of structured, semi-structured, and unstructured data. When we were working in SaaS, pretty much everything we worked with was structured data. So what are these other ones if you're not familiar with semi-structured or unstructured? Well, so with structured data, think of it like a SQL table, something that is, every column has like everything is in a column. That column is uniform. There are restrictions on it. In our particular case, anytime we're working with structured data, we're going to be storing it in the data catalog. Semi-structured data, well, that can be stuff that is mostly structured. There's some sort of architecture to it, but it doesn't always have to be. So for example, your CSV files, JSON files, XML files, things like that are good examples of semi-structured data. Things that, yeah, it can even include, say, I've got a CSV and everything is, a normal table that I would expect. And then the last thing is an image. Well, that image isn't like a standard string or numeric. So that would make it a semi-structured data set. And those semi-structured data files we put in our workbench. And then the unstructured data, such as text files, log files, images, audio, PDFs, whatever you want, those are going to be also stored in your workbench. Frequently, we will use the term like S3 workbench, but the workbench is, it's redundant. Your workbench is always going to be your S3. Of course, that's not to be confused with your workspace, and we'll hopefully ingrain that a bit better as we go through here. So I think we've seen this image a few times. I made some minor modifications to simplify it, but here is effectively what your CDR Databricks environment looks like. You guys are coming in as users. And in fact, I myself I come in as a user. I have, this Go Anywhere file management. This is UFM. That's a resource that I have. I also have Databricks environment. So when I spin up Databricks and I load into Databricks, what am I doing? First thing I need to do is have a compute cluster. I can use a SQL warehouse compute cluster, which is exclusively going to work with your structured data. Or I can use a standard compute cluster. And this can be a generic compute cluster. It can be a job cluster. There are other things we'll go into it. But your compute clusters can communicate with your structured data in the data catalog or database, as well as your unstructured data in the workbench. Now, note that the UFM, we'll talk about this a little bit later as well, it can communicate as well with your workbench for managing unstructured data. So these are the three pieces we really want to focus on. It's like, where is your processing and how are you communicating with your structured data up here and your unstructured data down here? I will also call out that structured data as we know it is actually broken into two pieces. There's your actual file folders and your data files, which are going to be like Parquet or Delta files, which are intended for distributed compute and optimized in that sense. And then there's like a table definition that gets set in what we call a metadata catalog. Currently, we're using AWS Glue. But it's anytime you call to your database, you're actually connecting to two different locations, and you're making this association between the two locations. So that's what I really want to familiarize yourself with is this workspace location, and then the compute clusters. Also, I will call out that, we've talked about here's your structured data, here's your unstructured data in the workbench, the database, but Databricks in and of itself also is where we're storing like our code, right? So our code can be is technically unstructured data, and that is within the Databricks workspace, which is maintained in this environment and separate from your workbench or your database. So where is the data? We just talked about this a little bit, but I also wanted to call out a couple features of your data. So if you're talking about unstructured data, such as your notebooks or log, so your notebooks here, in this particular case, we're going to store those in your workspace. That is is maintained by Databricks. I want to call it your workspace has 3 different types of workspace. There's your user's workspace, your org's workspace, and then a shared workspace. This whole section, everything that's in your workspace is technically maintained by Databricks, which means that if trying to recover something from here is a little more difficult for us, we have to go back to Databricks to try to recover. I do want to call out that also that who can access these locations. So if you've stored something in your user workspace, technically you are the only person who can access that. The org workspace, likewise, only people in your org can access that content. But anything that's in the shared workspace means that anybody with CDR Databricks, any of our users of this environment can access that. So really, we should never put anything in this shared location. I think I just want to really drill that home. The default permissions for any of these locations. So if I'm going to my user location, the default is that I can manage, so I can run it, I can edit it, I can do whatever I want. Likewise, in your org files, you can manage by default everything there. And likewise, anything in the shared location. So I could go into a shared location if somebody's put something in there and I can delete it. So clearly it's not what we want to be putting anything in there anyways. Your path examples, you'll notice if you ever look at it. So like for a user path, it's going to be your workspace /users, and then like your username. Your org will have like a workspace / and then like your org name. And then this third one, workspace shared, which again, we just should never use. The next type of unstructured data we're going to talk about are logs, or text files, PDF, things like that. Those all go into our workbench in the S3 location that's been assigned to your org. It's maintained by our CCSQ QDAS team, which means that when things are lost or going wonky with it, you can send in a help desk to us and we can usually identify, resolve the problem ourselves. And so it's a quicker turnaround on that. Also, only people within your org will have access to content within your workbench. By default, everybody would have within your org will have read, write, execute, and delete. So again, just be careful when you put things in there or when you're modifying those things that you don't accidentally delete someone else's work. This is all kind of what we're using, and I will call out that these are specific practices until we get, in the future, it will be changing a little bit better, some additional granularity. But at this level, at this time, this is what our primary practices are. In your path to your workbench, as many of you may have seen, is you've got a large S3 path that goes to your org, and then you'll have a workbench. And then everything below this is yours to do with as you wish. So you can create folders, you can delete folders, you can do whatever you need within this below the workbench location. Same with semi-structured data, your CSVs, Excel files, SAS7 BDAT files. They're on the workbench, managed by our QDAS team, and only your org has access to it. So the structured data again, is going to be in the data catalog. So those are tables, and the data catalog will have two components to it. Not only does each table have two components, but the data catalog basically has your org's schema and database. So anybody within your org can access it, and they can create, drop, select whatever they want within that. And then you have what I would qualify as like the CDR data catalog, which is enforced based on what your DUA is. And even with that DUA, you'll only have select permissions. So you can select the data from there that you want, run your code, and then output it into your orgs or do whatever else you need to do with it. But you're not going to be able to modify the content of those original tables. S3 paths, just to show you, just like you have like your org's S3 work path and you have your workbench, there's actually an analogous database path that sets all your managed files and helps us, it's all abstracted away from you, but that's where all your data is. So if you ever wonder, where's my org schema data being stored? It's actually being stored within your S3 bucket. And so it's protected by the same S3 protections that you have for your org. So I just wanted to show, an idea. Oh, here also, as I mentioned before, Databricks tables comprise of the data files and the table definitions. What do we get from the table definitions? Here's an example. When I do a describe extended on content within the CDR, you'll see, not only will you see, oh, here's all the column names and the data types and stuff like that, but at the end, you'll see that it's, what database it's in table, but you'll see it's a managed, and it's got the provider and it's got the location showing that it's in the database location of this PSA community. By the way, this CDR PSA community is something we're rolling out for all of you in our future trainings. It's just going to be demo data that we're able to refer to. That's not, so we don't muddle it in with like the actual public data, such as zip codes and things like that. You usually, when you run by yourselves, if you try to run describe extended, you usually won't see this level of detail on like the location and such. And this is mostly just because I'm listed as an admin in the system. But I did want to demonstrate that it does exist. We're not just saying it. Questions about the S3 mounts. We've heard, I've worked on help desk. I've received a few comments like, well, why is this not working? What is the S3 mount? Why do I even need to do this? So the basis of this is all of your data, the only, let me go back up here. So your workbench and the database are the only locations where you can store actual data. Your data, your reports, everything else, those are only to be stored in the database, like in the amongst the structured data in the data catalog, or in your workbench, your S3 locations. So, like I said, there is a workspace, and that is really only for code. So then, well, why do I care about an S3 work like mount? If you look at, when we spin up a cluster, every cluster has a driver node and it has multiple worker nodes. It's got at least one. It's going to have, it will spin up additional worker nodes based on the amount of work. Now, if you're working on the driver node and you want to access, say you run you want to read data that's in your S3 location. The standard process is just going to actually only communicate through the driver node and only process on the driver node. So if you want to really leverage all of these additional worker nodes, then the only way to do that is to do it through what we call the Databricks file system, which has a mounting portion. And so by doing an S3 mount, what you've effectively done is extended the Databricks file system to include your contents within the data within your bucket, and your worker nodes can now directly access that. Now, to clarify, although the directories are listed in there as a mount, access to the content and further information of your bucket is still going to be restricted based on the permissions enforced by your S3 bucket policies. So only your org or only members of your organization are going to be able to see the content, even if you've got this mounted. So this is the whole reason why we want to do S3 mounts, is just to make sure that you can leverage the entire efficiency of having a cluster, and allow your worker nodes to directly communicate with the mounts, the mounted location, or your S3 workbench content. So how do we do this? First thing you have to do is you have to pick a unique mounting name. Here I've created one. It always has to start with a /MNT / and then the _QDAA. That's my unique name. Q- because I work on the QDAS, kind of adminish side, _ my initials, or DAA. I want to confirm that the mount name is unique, because if I try to mount and that mount already exists, it's going to fail on me. So I can run display of all the mounts, and I can see every mount that exists. Mounts are perpetual, so they have to be unmounted. Otherwise, they will always be in here. I can then create the mount by using this command of fsmount, setting my S3 path to my workbench location. And I can stop it at workbench, or I could go even further down. In this particular case, I'm going specifically all the way down to this folder of Anders DA. Set the alias here, or my unique mount name. And then from then on, I can just reference directly through this mount for the /mount / my mount name. So here's how I would get a listing. I would write. Anytime I would have to reference content in my bucket, I would just reference it as being within this mount q-daa. And then, like I said, mounts are perpetual until the environment itself is taken down. So that doesn't really happen. So each team can come up with their own practices, but for me, I prefer to unmount at the end of every session, just to keep kind of a cleaner space. I've run this just to show, for example, in this particular case, I ran the dbutils fs mounts. I can see all these mounts as of whenever I ran this at 11:38 this morning. And again, I did it to confirm that there is no QDAS DAA. There's Oren has one, and I can see to what path they go to, but then I can't see any content. So I've confirmed that that didn't exist. I then run the mount. I get a true return successful. And then I just run a listing. In this particular case, I just had two folders in here. I could follow down further and do whatever I need to within there. As I mentioned, this mount that we're creating is actually an extension of the Databricks file system. So you'll see when I run the path here, it's showing me dbfs /. That is, that's to be expected. When I'm listing the mounts up top here, this particular command obscures that portion. No particular reason. It's just to simplify it here. But they're referencing the exact same things. And then I've unmounted. And when you've successfully unmounted it, it returns that it's unmounted and a true statement. Another question we get frequently is about unified file management. So what is it? Why do we need it? How do we use it? So ultimately, unified file management is a CCSQ tool that's used for secure file sharing and delivery. It does have an optional feature that establishes a secure connection between your local desktop and your org's workbench. So this is useful if you need to manually upload data to your workbench or download reports from your workbench. And it's a useful side benefit of it is it gives you kind of a visual method of exploring the folder content in your workbench until we get, until we're able to make that capability available within Databricks. If you don't have this network connection, how do you go about doing it? You can contact our help desk and actually just verbatim copy paste this out. Just say you're requesting a workbench, a network folder to your workbench, provide your HARP ID and the S3 path. And then we will process that on your behalf after verifying the S3 path. You can also submit for multiple HARP IDs at once. I personally am of the belief that you give minimum permissions necessary. So if I have people on my team, but they don't do anything with data, then I'm not necessarily going to automatically request the network connection to them. But that's also up to you guys and your organization as you decide to set your own practices. If for some reason you're unable to find the S3 path or you don't know what it is to your workbench, I request that you speak to people in your team. They may know it. Also, your core should have that content. As a final resort, you can submit a ticket to the help desk to try to find that for you. It's just, as with most things that go through help desk, you're going to have a longer lag time before it gets to the proper people. But how do I use it? All right, so here you'll see in my apps, there's a screenshot. I've got the Go Anywhere managed file transfer, which has been kind of rebranded as Unified File Manager. So you'll select that. Your landing page will show you you've got team folders, which is probably what you're most used to. And that's what's like default set up for you. But these network shares folder is what you really need to have set up. I go into my network shares, I can drill down to my workbench, and then I go into, whatever location I need to. I can click on upload and it will open up kind of the standard browser upload window that you typically see. And then after you select that, then you just wait for the confirmation. It will show that it's working. It'll give you a little dial. And then eventually, it will show up as saying confirmed. There are limitations, particularly with size based on which browser you're using. But typically, I think it's between 2 to 4 gig file size. If that's insufficient for your needs, you can reach out to our teams and we can try to find alternatives. There are some people may be familiar with, but there are ways of doing a BYOD, where you bring your own data and the connections to be able to bring it in through a standardized pipeline. Some best practices that I would like to share about UFM. We have had reports of unexpected folder permission behavior if the folder was created within UFM. So, in UFM, you can select new folder and create a new folder. The alternative may be better where you go into Databricks session and you specifically list out like a DB utils fs make directory. Also found that the content that you upload through UFM are best used as read only. Trying to commit additional edits to the same file can lead to problems. So typically, it's just if you need to make edits to the exact same file, just make a copy of that file somewhere within Databricks. So, and then talking about data, where should I store all my stuff after I've done my analysis? What should I do with it? Well, honestly, we do kind of dictate in the sense that your data is only permitted to be in the workbench and in the data catalog. Beyond that, we've intentionally given you open permissions to control what's within your workbench, your workspace, your data, and even aspects of the data catalog. Your orgs are to be held responsible for that. And so, keeping those spaces clean, we encourage that you create guidelines or standard practices. Some ideas, for example, within my workspace, maybe I'll do my initial development work in my personal space. And then once I'm ready to start testing it or having the rest of my team needs to use it, then I can just move it to my org's location. Within my own location of my user space, I can create as many subfolders, so I can create sub projects or whatever else I'm working on. Likewise, within my org, um, I can add additional folders that are specific to the task name, whatever. Um, for structured data in the data catalog, we recognize that there's only one schema assigned per org. So in those particular cases, you'll need to focus on probably nomenclature practices. One suggestion could be, you have your org schema, then maybe user initials, followed by an underscore and some sort of data set name or description, underscore date. Whatever works for you in your team to be able to identify who's created something and who's responsible for it. And maybe even, sometimes I prefer when other people have put their initials on it, because then I know I'll just leave it alone, or know who to go to if I need to access it or use it myself. For semi-structured data or unstructured data in your workbench, again, we've given you the full access beyond your workbench location. So once you can put in like a team, you can put in a task name, you can put whatever, you can do a customized user name, something along those lines. Again, we're not on your projects, and so we want to give you that flexibility as best we can. The only limitation really has been with the structured data catalog. But if something really isn't suiting your delivery needs or your work, always feel free to reach out to us, and we will engage with you and try to explain maybe or identify a better solution. So that's kind of the data-centric part of it. For best practices in compute clusters, and I want to point out, at this time, we currently have all-purpose compute clusters. And we also have those that are with, let's say, R only, and then standard. The R only ones is actually a misnomer. At the time when they were created, they were just for R. But it will do all of them, including R, whereas your all-purpose compute that doesn't have the R listed on it, I believe won't handle R. It still won't handle R. So if you need to do R, stay on the R only. If you need to do a mixture of R with other stuff, do R only. If you don't need to touch R, you can stay with the all-purpose here. We have SQL warehouse compute clusters and job clusters. I want to point out, the all-purpose compute clusters have access to everything in the data, to your content in the data catalog, as well as your workbench. SQL Warehouse only has access to the data catalog and content that is for structured data. And then job clusters have access to the data catalog and workbench. Customization levels vary based on what you're trying to use. A job cluster, you can customize some of the size and libraries. At this time, there's not much that you can customize on the SQL warehouse and even on your all-purpose compute. Other things that we're working on is, you have to consider when looking at which compute process or which compute situation do I need. Well, also look at, your all-purpose computes are currently shared by your entire org. So everybody within your org is targeting the same driver node and same worker nodes. So although it won't confuse your work, if somebody else is hitting it, they're still separated out processes, but they are still using up the same amount of RAM and have to share those resources. A SQL warehouse is currently shared by all users, but then your job clusters are unique to the job itself, and they will start up and shut down on their own, but they don't share the resources with any of your other org teammates. All-purpose compute is great for, some examples are like if you're developing new code, or you're importing data and you need to be able to look at it in between. Those are great ideas, especially if you're, testing it out. If your SQL warehouse can be good for, data exploration, saved queries, automated queries. And then job clusters are really ideal for executing production code. Perhaps you'll want to develop the code in the all-purpose compute. You're deving it. You're not really targeting all of the data. You've got filters on it, so you're subsetting just limits of maybe 500,000, something along those lines. But then when you're ready to do it on everything, you can run it through a job cluster. We mentioned that libraries can be customized. So I want to point out to you is that you may or may not know, but first you can use pip install or install anything that's in the Python package index. Also anything that's in the comprehensive R archive network. However, I do recommend that you first look for things that are compatible with distributed computing and Spark libraries. We've also preloaded some libraries onto your stuff beyond just the standard Databricks stuff. All of your compute clusters actually have this Spark to Excel, this Spark Excel and Spark SAS 7 BDAT, which will use you can read in SAS 7 data files. So especially your larger SAS 7 BDATs on your workbench can be read in using your worker nodes. And so you don't have the same space restraints as you did previously. And this Spark Excel will allow you to read in Excel files as well as output Excel files. Documentation, I've included links here. Documentation is a little lacking on these, but these are open source tools that were, provided to the community at whole, and we've been able to kind of get them vetted and brought them in. Another best practice that I do want to share is we don't want to over-engineer things. So when you need to create a function, I'd highly recommend, granted it's not like a simple thing like, oh, I'm just wanted to do some listings and run some error checks for me or something like that. But if it's like a heavy processing functionality, I'd verify that the functionality doesn't already exist. So check the documentation. It can be tedious, but Spark is the base of Databricks. So look at both the Spark locations as well as the Databricks. And the reason I mention this is because anything that's in Databricks or Spark has been optimized and been, put together by, much better developers than most of us. And whatever you create with your best of intentions is probably not going to perform any better than what they've already created. So if there's something that's close enough that you can use, I would try to leverage that first. If not, then I just would recommend that you use your clear annotations. We're going to go into have more office hour content about ideas for designing your proper functions, your own custom functions, and deploying them. But for the time being, just make sure you use clear annotations, provide clear documentation, and really understand like what your input and output data types are, particularly, and list any dependencies. And then we highly recommend that you consider sharing it amongst your own team. As we've talked about yesterday, our goal is to we're actively working on creating like a shared repository of programs and functions that other people can utilize within the CDR environment. So those are things that I would like to share. In conclusion, I just wanted to kind of focus on, we were interested in having greater familiarity with the CDR Databricks environment architecture. So remember this, how things are connecting to your database and to your workbench, and where it is that you're storing stuff and who manages that, or who can kind of troubleshoot your issues on those. Um, we wanted to increase your clarity of the different storage locations and intended uses, right? Like your notebooks go into this one unstructured location of your workspace, and you have user, org, and shared. Um, as compared to the other unstructured stuff, such as your text files or logs, um, which would be in your workbench, semi-structured, and then your structured content. And then again, we're trying to make everything. We're trying to give you all the tools that you could potentially need. So I know sometimes it's a little difficult to hear, like when people are like, oh, well, how do I do this? And our response is, well, what are you trying to do? Who needs to use it? What type of data is it? Because all those feed into the proper design of your solution, the proper implementation of all the tools at your disposal. So, try to keep just in mind the difference between these different your all-purpose computes, your SQL warehouse compute, your job clusters, your utilization of the S3 mounts, and the network connections for your ad hoc upload, download stuff. Some common questions we get before I go on into opening up for Q&A is just, which compute resources should I be using? Well, again, depends on the purpose, the language that you're using, the type of data you're accessing, and how much of that data you're going to be processing. If you're going to be processing a lot of data, you're probably going to want to do a job cluster. If you're accessing data that's on your workbench, then you can't use a SQL warehouse. You'll have to use a different compute cluster. Where can I, people are asking, where can I, have control and create subfolders and organizations of my own formatting? You can do that within your workbench and your workspaces. Again, for your workspaces, it should only be code that you're putting in there. Workbenches are specific to all the data and data artifacts, including your reports and your logs. How can I upload content to be used by Databricks? We talked about the network connections. And finally, people do ask, can I use pandas, or can I use some new fancy library you've heard about? General answer is, if it's in PyPy, like the Python repository or the R repositories, then yes, it should easily be able to be installed on your cluster. However, if it's not in those locations, such as what we've loaded on with the Spark Excel and Spark SAS7 BDAP, it doesn't mean that it's not possible. There's a bit more of a process in doing so, but reach out to us, let us know, and we can help you. I have additional resources listed here, talking about our transition resources in Portal, some Q&A stuff that we've listed there, office hour recordings that we've got in there, the latest announcement about job cluster creations. And then if you need help, here's a link to the process for requesting for a help desk ticket, or also I do recommend reaching out to on Slack, the CCSQ data analytics channel. Some of your peers probably have dealt with the same issue you have, or are more familiar with the data itself. So that concludes my presentation. And like I said, I can be verbose. So any questions?
Right now, Dan, all questions have been answered in the chat itself, and we don't have any outstanding.
Perfect. Love to hear it. I've got a great team that I work with, Oren, Derek, and you will all be seeing more of Chris Martin and some additional resources. We're all trying to get you all the help you need to be able to successfully migrate and leverage um, all the capabilities of Databricks for your future work. So, thank you very much.
You're getting some good feedback there in the chat as well, then, Dan.
Thank
Um,
you.
So thank you so much to Dan for our session 8. So we are going to move to session 9 here in about 15 minutes, and we're going to take a short break. Session 9 is going to be object-oriented programming 101. So thank you so much. And then following that directly after is going to be some closing remarks from Ken Howard. So make sure you stick around for those as well. So thank you so much to Dan and all of our attendees for a great session 8, and stay tuned for session 9. We'll see you back here at 4 p.m. Thank you.